Hello everyone, welcome. I'm the student of Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Engineering. Here the subject is about software development and the project management. Let us discuss about the cybersecurity in the software engineering and project management. Cybersecurity is a critical component of software engineering and project management that ensures the protection of sensitive data, systems, and the infrastructure from the cyber threats by integrating the security best practices throughout the software development life cycles. Organizations which can build and secure the resilient applications. Defining cybersecurity in the tech industry: data protection, system security, risk mitigation, compliance. Data protection: safeguarding the sensitive information from the unauthorized access that are a manipulation. System security: that ensures the integrity and the availability of the software systems, networks, and the infrastructures. Risk mitigations: identifying, assessing, and the implementing controls to minimize the impact of cybers. Compliance: adhering to industry regulations and standards to protect the sensitive data and the assets. Importance of cybersecurity in the software development: secure by design, proactive protection, compliance, and the regulations. Incorporating security best practices from the initial design phase to in order to reduce the vulnerabilities. Proactive protection: it is anticipating and the mitigating potential cyber threats in order to maintain the business continuity. Compliance and the regulations: ensuring the software products and the service adhere to industry standards and the legal requirements. Integrating security best practices into the SDLC, that is software development life cycle. It includes planning, design, implementation, testing, and the deployment. Planning: it's identifying the security requirements and the objectives early in the development process. Designing is incorporate security principles and the patterns into the software architecture. Implementation: that secures the coding practices, coding reviews, or a strategic analysis to minimize the vulnerabilities. Testing: that performs the penetration testing, vulnerability scanning, and the security audits throughout the development. Deployment: implementing the security deployment process and ongoing monitoring for the potential threats. Cybersecurity includes the key considerations, which are cybersecurity in a software development, cybersecurity in a project management, challenges in integrating cybersecurity, and the best practices for cybersecurity in both domains. Cybersecurity in a software development, which includes it secures the software development lifecycle, which is SDLC, common security vulnerabilities in software, and the secure coding standards. Cybersecurity in project management includes risk of management, stakeholders communication, and the incident response planning. Challenges in integrating the cybersecurity, which involves balancing and securing the with usability, cost and resources, and evolving the threat landscapes and the legacy systems. Best practices for the cybersecurity in both domains, which includes early and continuous security involvement, use of encryption, and the patch management. Risk assessments and the vulnerability management, risk identification, risk analysis, risk mitigations, and the vulnerability monitorings. Risk identification: that systematically identifying the potential threats, vulnerabilities, and their potential impact. Risk analysis: that assess the likelihood and the security of the identifying risk to prioritize mitigation efforts. Risk mitigation: that implements the appropriate security controls and the countermeasures to reduce the identified risks. Vulnerability monitoring: continuously that can scan further and patch known vulnerabilities in order to maintain the security posture. Secure coding principles and the techniques, input validation, authentication, authorization, and the encryption. Input validation that sanitize and validate all user input to prevent the common injection attacks. Authentication that implements the strong authentication mechanisms in order to verify the user identities. Authorization enforces the granular access controls to resources based on the user permissions. Encryption that protects the sensitive data to reset them and in transit using the strong encryption algorithms. Access controls and identity management, authentication, authorization, and the identity life cycles. Authentication verifies the user identities throughout the strong login credentials and the multi-factor authentication and the biometrics. Authorization enforces the granular access controls based on the user roles, permissions, and the least privilege principles. Identity life cycles that manages the complete life cycle of a user identities, which involves the provisioning, modificationing, and the deprovisioning. Incident response and the disaster recovery planning, preparation, detection and analysis, containment and the eradication, recovery and the lessons learned. Preparation, which established the comprehensive incident response plan and the travel personnel. Detection and analysis that quickly identifies and investigates and also determines the scope of the security incident. Containment and the eradication implements the measures to stop the incident, mitigate its impact, and remove the threat. Recovery and the lessons learned restores the normal operations, reviews the incident, and improves the security posture. Fostering a culture of a security awareness, employee training, educate all personnel on a security best practices, policies, and the incident response procedures. Security champions that identifying the empower security minded individuals in order to advocate for and implement security practices. Continuous improvement regularly review and update security measures to address the evolving threats and regulations. Collaborative efforts fostering a security conscious culture where all the team members actively participated to cybersecurity reliances. Here the conclusion, cybersecurity is an essential component of modern software development which ensures the application and resilience to the increasing number of cyber threats. By integrating security throughout the entire software development lifecycle, from the initial requirements to coding, testing, and the deployment, developers that can proactively addresses the vulnerabilities and the safeguarding the data, which secures the coding practices and the regulating the security testing and adherence to industry standards and building the robust and the safe software systems. Thank you.